Dear students, welcome back to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So yes, today is Sunday, and as we do every Sunday a mock test. So today it's in today's we are in KPL 9, right? So today's syllabus was your complete inorganic chemistry of PU2. Okay, so in this video I'll be discussing the solutions, and I hope all of you would have downloaded the question paper from our WhatsApp channel or from our community post and would have solved these questions, right? So now what is your duty? You need to check the solutions and you need to assign yourself mark. So for every correct answer you need to give +1 to yourself, and for every wrong and unattempted questions you need to give 0 marks to you. Okay, and after that do not forget to comment down your scores. So now let's get started. So portion, as I tell you, the complete inorganic chemistry of PU2, that includes 2 chapters, DNF block and coordination compounds. Okay, so yes, now let's get started with the first question here. Okay, in which one of the following pairs both the elements does not have n-1 D10 NS2 configuration? Does not have, both the elements does not have this configuration. Now let us first write down zinc, cadmium, mercury and Cn configuration. Zinc, if you know, it is 3D10 4s2, cadmium 4D10 5s2, mercury 5D10 6s2 and 6d10 7s2. Okay, so now if you see zinc and cadmium both are having n-1 D10 and ns2 configuration, so this cannot be the answer. Cadmium and mercury also are having n-1 D10 and ns2 configuration, cannot be the answer. Hg and Cn are also having, so that also cannot be the answer. Now if you see copper and zinc, copper electronic configuration is 3D10 but 4s1. So there is no ns2 configuration in copper. So that is why copper and zinc are those pair where both the elements do not have n-1 D10 and ns2 configuration, right? So the correct answer will be option number D here. Next, the electronic configuration of transition element X is +3. Oxidation state is Ar3D5. What is the atomic number? Okay, so they are telling that X is an element in +3 oxidation state. It has a configuration of Ar3D5. Okay, you need to tell the atomic number. So now if you see, okay, argon. So if I now X atom, if I only take here +3 means 3 electrons were lost. Now I can add 3 electrons here. So argon, and I need to add 3 electrons. So 3d6 and 4s2, right? So that means what? If you see the total here, it is argon is 18, right? Here 6 electrons and here 2 electrons, that is 26. So this element is nothing but iron, and the atomic number is option number B, that is 26. Next question, the electronic configuration of gadolinium 2+ is. Okay, so if you see, we have the gadolinium configuration is like this, Xe, okay, 4f7 5d1 and 6s2, gadolinium configuration. Now if it is gadolinium +2, these 2 electrons will be lost. We will have 4f7 and 5d1. So the correct answer for this question will be option number B. Okay. Next, which of the following is correct with respect to the melting point of a transition element? So if you remember, melting point, what is the order of melting point? Melting point depends on metallic bonding, right? Metallic bonding, and metallic bonding is dependent on the number of unpaired electrons. Okay, so what we have observed is, as we go along the period, as we move along the period, number of unpaired electrons first increases, right? D1, D2, D3, D4, D5, D5. Up to that, the number of unpaired electrons is more, right? After that, the number of unpaired electrons start decreasing, so melting point also start decreasing. So that is why if you see, we have first scandium, then titanium, then we have vanadium, then chromium. Okay, then manganese has a drop in the melting point. So what I can say, that chromium is having the highest melting point in the whole series. So that is why here you see that it is given vanadium is having more melting point than chromium, which is not true. So that is why option number A is the here the question is which of the following is correct. Okay, sorry, this is then incorrect, right? So this cannot be the answer. Okay, then manganese is the one which is having the lowest melting point. So manganese is having more than Fe, that is also wrong. And titanium, if you see, vanadium will be having more than titanium, so this relation is also wrong. Chromium having more than manganese is correct, so option number B is the correct relation. Okay. Next, a transition metal exists in its highest oxidation state, it is expected to behave as. Okay, this is also very good question. Now see, if it is in the highest oxidation state, highest oxidation state. Okay, now if an element is in its highest oxidation state, that means it has lost many electrons. Okay, now if it is having if it has lost many electrons, now what it can do, it can gain electrons. If it is gaining electrons, that means it is undergoing reduction. If it is undergoing reduction, it will behave as an oxidizing agent. So the correct answer will be option number A here. Next, which of the following are amphoteric oxides? This is direct memory based question, so you must remember the examples of amphoteric: V2O5 and Cr2O3. Option number A. Here you should remember that if the oxidation number is highest, okay, then generally they are acidic in nature. Okay, and if the oxidation number is low, then they are basic in nature. If it is medium oxidation number, okay, then it behaves in amphoteric nature. Okay, clear? Next, the bivalent metal ion having maximum paramagnetic behavior among the first transition element series is. So for paramagnetic behavior means you need more number of unpaired electrons. Whichever option is having more number of unpaired electrons, there the paramagnetic behavior will be maximum, right? So for maximum paramagnetic behavior, what we need? More number of unpaired electrons. Okay, so for that you should remember the electronic configuration of different elements. Once you know the electronic configuration, then only you can calculate the number of unpaired electrons, right? So manganese 2+ is having 3d5 configuration, so number of unpaired electrons is 5. Copper 2+ is having 3d9 configuration, number of unpaired electron is 1. Scandium 2+, scandium formula or the number of electronic configuration is 3d14s2. So with scandium 2+, it is 3d1, number of unpaired electron is 1. Copper plus configuration is 3d10 and it has 0 unpaired electrons. We need maximum paramagnetic behavior. You can see the maximum number of unpaired electrons is 5. So that is why correct answer is option number A here. Next, Mn2+ compounds are more stable than Fe2+ towards oxidation to their +3 state because. So the question here is saying that, see, Mn2+ is there and Fe2+ is there. Both wants to, suppose I want to oxidize both of them to Mn+3 and Fe+3. It is seen that Mn2+ does not undergo this conversion, or it is very stable towards this conversion. Now what is the reason for that? That is very obvious. See, here the configuration is D5, here the configuration will be D4, right? If you remove one more electron, it will become D5. Here it is D6 and here it is D5. Now there is something special about this D5 configuration. What is it? It is half filled configuration. Right. Now manganese is already in a very stable state in Mn+2 oxidation number. It is already very stable, right? So why does it want to go to +3 state where it is unstable? So that is why it is resistant, or it is stable towards +3 conversion. It doesn't want to go to +3 state. So that is because Mn2+ is more stable with third ionization energy, right? This third ionization energy is very, very high because you are converting from a very stable species to a unstable species. So option number A is the correct answer here. Okay. Next, which one of these following is not known? Okay, so here also you should remember, this is important question, that copper 2 plus, okay, oxidizes I minus to I2. That is why we do not find Cu2I2. This is the one which is not obtained. Okay, so correct answer is option number B here. Next question, the only lanthanide which is radioactive. So this is direct theory based question, that is your promethium, option number A. Next, the elements in which the electrons are progressively filled in the 4f orbital are called as lanthanoids, right? Direct definition based questions. Which of the following oxidation state is common for all lanthanides? That is +3. All lanthanides has a common oxidation state of +3. Next, incorrect statement with reference to Ce. Okay, Ce plus 4 is a reducing agent. Now see, Ce plus 4, okay, it is the highest oxidation state of cerium. Okay, so now what can happen? Ce can come to lower oxidation state of +3. It cannot further go to any other higher oxidation state. Now if it is undergoing reduction, right, here it is a reduction, then it will behave as an oxidizing agent. It cannot behave as a reducing agent. So that is why this is the incorrect statement. Hence the correct answer will be option number A. Okay. Next question, the transition element present in lanthanoid metal in mic metal. So this is no alloy of lanthanoid. So 5% is which one? Iron is present in 5%. Option number B is the correct answer. Next, this is important question here again. How many moles of acidified K2Cr2O7 is required to liberate 6 moles of I2 from an aqueous solution of I minus? Okay. So first of all, it is saying that first you need to understand the reaction. See what happens, Cr2O7 2 minus plus I minus gives you Cr3 plus I2. Okay, now what is this? Now see, what is the oxidation state of chromium here? Chromium oxidation state is +6, right? So now +6 to +3, it is requiring 3 electrons, right, or 3 moles of electrons. But see, there are 2 chromium here, right? So definitely here also I need 2 chromium. So if I want to write like this, Cr2O7 2 minus plus 6 electrons, okay, will give you 2 Cr3 plus. Can I write like this, right? Yes, this is for 2 chromium, right? Now I have not balanced the oxygen atom because that is nowhere required in the question. Clear? +6 to +3, okay, we require 3 electrons. If you give +6 charge, if chromium is in +6 state, and if I get 3 electrons, I will get chromium +3. But here it is Cr2, 2 chromiums are there, so this side also 2 chromiums will be there. So that means for 1 chromium, if it is 6, 3 electrons are required. For 2 chromiums, it will be 6. So that is what I wrote here. Okay. Now let us see the about iodine. Now if I see about iodine, I minus will give me I2, right? 2I minus will give me I2, right? Now here you can see that, okay, one second. Yeah. So now here we can see that I minus, okay, will be converted to I, right? For this we need 1 electron, right? But again if you see, I2 will be produced, so 2I minus should be there, so 2 electrons should be there. So this will be the conversion here, right? Now if to balance this reaction, the number of electrons should be same, right? Number of electrons means here I should multiply it with 3. So what will I get here? Cr2O7 2 minus, okay, plus 6I minus will give me 2 Cr3 plus, okay, plus 3I2. Okay, this is the reaction that we are getting. Now according to this question, or according to this, what I can say that to produce, one second, yeah, this one will be 6I2, sorry, this reaction it will be 6I2. Okay, Now you can see 1 mole of Cr2O7 is required to produce 6 moles of I2, right? 1 mole of Cr2O7 is required to produce 6 moles of I2. That is what is the question asked. How many moles of acidified K2Cr2O7 is required to liberate 6 moles of I2? So for 6 moles of I2, I require 1 mole of potassium dichromate. Option A will be the correct answer here. Okay. Next. This is also important question. So now we have entered to the coordination compounds chapter. Addition of AgNO3 to an aqueous solution of 1 mole of PdCl to 4NH3 gives 2 moles of AgCl. If 2 moles of AgCl is produced, that means 2 chlorine will be outside the complex, right? So what will be this one formula? Pd, right? Then I have NH3 whole 4, okay, and Cl2, right? Now if I write, what will be the charges of this one? Pd NH3 whole 4 plus 2 and Cl minus, right? So this is a 1,2 type electrolyte, because here the charge is plus 2, here the charge is plus minus 1. So this is 1,2 type electrolyte. Option number C is the correct answer here. Next we have homoleptic complex among the following. So this is also very easy question. What is homoleptic complex? Same type of ligands, or same ligands should be there, right? Same ligands. Now here you see all are same ligands. Here you see 2 mixture of ligands are there. This is not homoleptic. Here also you can see all the 4 are hydroxide ions are present. So 1 and 3 will be the correct answer. Option number C. Next, which among the following is the strongest ligand? Okay, so CO is the strongest ligand. If you have learned the spectrochemical series, option number C will be the correct answer. Next, the coordination number and the oxidation state of the element in this particular compound you have to find out. Okay, coordination number and oxidation state. Okay, so now if I see this is MEN2 and we have C2O4. Now if you see that En and C2O4 both are bidentate ligands, okay, bidentate ligands. Now what do you mean by bidentate ligands? Each molecule forms 2 bonds. Each molecule or each ligand forms 2 bonds. So there are total 2 En. 1 En is forming 2 bonds, 2 En will form 4 bonds. So En will form 4 bonds here and C2O4 will form 2 bonds, right? Because this is a bidentate ligand, 1 ligand forms 2 bonds. So total how many bonds will be there? 6 bonds. So metal is forming 6 bonds, that means the coordination number of the metal is 6. So we can eliminate these 2 options. Now talking about the oxidation state. So let MBX, En is a neutral ligand, 0, C2O4 is minus 1, NO2 is minus 1, that is 0, we will get plus 3, right? So the correct answer will be 6 and 3, option number C. Okay. Next, the number of isomers possible for the octahedral complex here. This is also very important question here. Okay. So first of all, let us see what are the isomers possible. We have CO. I can draw like this. Okay. NH3 and NH3. Okay. Now what happens in this particular molecule? You can see that there is a plane of symmetry. Okay. If there is a plane of symmetry, that means what? The upper part and the lower part exactly same to each other. If there is a plane of symmetry, then it is optically inactive. It is optically inactive, right? So this is, it will not have its enantiomer. Okay, you cannot draw its mirror image, non-superimposable mirror image will not be there. This is one. Now I can draw one more like this. Instead of Cl, I'll take NH3 here. Okay. Now here also I can have a plane of symmetry. That means this is also optically inactive. So first I got one isomer here, second isomer here. Now what I'll do is, I'll take one more like this, where I'll have CO, Cl, Cl, NH3, NH3, and then I have En. Okay. Now if you see, we do not have any plane of symmetry here. There is no plane in this molecule in which you can divide the molecule so that both the halves will be equal. It is not there, right? That means if there is no plane of symmetry, that implies it is optically active. Now if it is optically active, then it will have a mirror image of this one, right? There will be mirror image which is also enantiomer, right? So we will get 1, 2, 3 and its mirror image 4. So total 4 isomers, option number D. Next, which formula and name combination is incorrect? Okay, so first we will see potassium, trioxalato, aluminate 3. This is correct. Now if you see option number C, okay, I am coming directly to the answer here. This En, this 2 should be written as bis-ethylene diamine, right? Di will not come. We have to use the word bis. Because it is written di, this is incorrect. Correct answer will be option number C. Okay. Next, IUPAC name of cisplatin. So if you know the platinum structure, cisplatin structure is like this, right? Cl, Cl. So we have diamine dichlorido platinum, okay, but here if you see the charge of platinum is +2, okay, so that is why +2. Option number C is the correct answer. Next, the formula of penta-aqua nitrato-chromium 3 nitrate. Okay, so first of all we need penta-aqua. Here there are 6, eliminate these options. Okay, next we have let us now write down. So penta-aqua means, yeah, we have chromium, then we have penta-aqua. Okay, you have then nitrato means 1 NO3 is also there. Okay, then you have nitrate. Okay, here it is very important how to find the charge. Now see, what is the charge of chromium? +3, water is 0, nitrate is -1. That means this total complex charge is +2. Nitrate charge is -1. Then what will happen? There will be crisscross. So what I will get? Cr, okay, H2O whole 5, NO3, NO3 2. Okay, so that is option number C. Okay. Next, question number 25. Which of the following system in an octahedral complex has maximum number of unpaired electrons? We need maximum number of unpaired electrons. So for that you should know how to write the electronic configurations, right? D9 high spin. So what is that configuration? If you have like this, we have T2G and EG, right? D9, 1, 2, 3, 4, 5. Sorry, we need high spin. So pairing will not take place. First there will be, first it will go to the higher level. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So what is the configuration here? T2G6, EG3. Okay, that is the first thing. Then D6 low spin will be only T2G6. So in this T2G6 EG3 I have one unpaired electron. T2G6 there is no unpaired electron. D4 low spin 1, 2, 3, 4. So that is T2G4. Here I have two unpaired electrons, right? Next D7 high spin 1, 2, 3, 4, 5. So that is T2G3 and EG2. So number of unpaired electrons here is 5. So that is why correct answer will be option number D, because it has the maximum number of unpaired electrons. Okay. Next, crystal field splitting energy for this one is 18,000. What is the crystal field splitting for COCl4? So here you should know a relation of delta T is equal to 4/9 of delta O. So crystal field octahedral splitting 6 coordination number is there. So this value is nothing but 18,000, right? So that means I'll get 8,000. Option number A is the correct answer. Next, the correct order of wavelength of the light absorbed in the complex ion. So this is again an important question. Okay. So first of all, see the splitting. Okay, splitting of the complexes, the d orbital splitting depends on what? Depends on the ligands. Okay, now if so, I'll write like this. See, if there are strong ligands, if we have strong ligands, then what will happen? There will be more splitting. Okay, if there is more splitting, energy will be high. Okay, high energy means there will be less wavelength. Why? The reason is E is equal to hc by lambda. If energy is high, wavelength will be less. Now if you see these ligands, NH3 ligand, then we have CN ligand, and then we have chlorine ligand, right? So that means where according to the splitting, if I write the order of splitting, okay, just I am writing the order of splitting of these complexes, then this one will, like third, I'll write only the numbers. Okay, yeah, so third one will split highest. Why? Because it has CN ligands. After that, which one will split? After 3 it will be 2, right? And after that 1. Splitting will be in this way, right? Because here you have 5 NH3 group, here all the 6 are strong field ligands. Then if the splitting is in this way, then energy order will also be like this, right? But wavelength order will be 1 will have the highest wavelength, then 2, and then 3. Okay, so correct answer for this question will be option number A. Next, complex ion having the minimum magnitude of CFSE. Again the same thing, the splitting. Okay, splitting, or I can say CFSE, depends on the strength of ligands. Depends on strength of ligands, right? So here you see what is the order of the ligands. We have CN. Okay, after CN we have NH3, then we have H2O, and then we have CN. So this is having the strength of the ligand. Here is minimum, splitting will be less here, so correct answer will be option number D. Next, the correct statement is, okay, CONH3 whole 6 2 plus is paramagnetic. No, here the hybridization is D2sp3 and there is no unpaired electron, so it is not paramagnetic. MnBr4 2 minus is a tetrahedral. Yes, this is correct because it has sp3 hybridization, so correct answer will be option number B. Now COBr2En2 exhibits linkage isomerism. No, because for linkage isomerism I need ambidentate ligand, which is not present here. Next, this one is a inner orbital complex. No, this is a outer orbital complex. Okay, so correct answer will be option number B here. Okay, next the complex, 2 complexes are given to you R. So you can see if you dissolve this one in water, we'll get this ion and bromine. If we dissolve this one, then we'll get this ion and SO4, right? So these are your ionization isomers. Correct answer is option number D. Next and the last question, which of the following statements are true about COF6 3 minus? So first of all, let me tell you, COF6 3 minus hybridization is sp3d2. Okay, octahedral geometry, yes, coordination number 6 has only one geometry, that is octahedral, so this statement is correct. Coordination number of cobalt is 3. No, coordination number of cobalt is 6. And oxidation number, no, this is incorrect. The complex is having sp3d2, yes, this is correct. It is a high spin complex, this is also correct, right? So we have correct statements 1, 3 and 4, that is option number C is the correct answer here. Okay, so yes students, these were the solutions of the KPL test and I hope you would have scored really well. Please do not forget to comment down, and if you have your scores and if you have any doubt in any question, that also you can address. I'll definitely take care of it. Okay, thank you for watching, and please remember your target. You have to score 60 out of 60 and work hard students. This is like very crucial time now going on, so please attend the mock test regularly. Okay, and that is a request, and all the very best. See you soon in the next class.